Welcome back, dear listener, to Sleepy Science History. I wonder, have you ever looked up at the night sky and felt a tiny itch of curiosity, like a whisper in the back of your mind? Maybe you've caught yourself asking, what if time isn't as fixed as we think it is? Could we, one day, slip through its seams, tiptoe into yesterday, or wander gently into tomorrow? Tonight, let's let that question linger in the air, soft and slow, like steam rising from a cup of tea. Is time travel scientifically possible? I'll be your quiet guide, not rushing, not lecturing, just walking alongside you, step by step, as if we're exploring an old library together. Imagine the wooden shelves, the warm glow of lamps, dust motes dancing lazily in the beams of light. We'll take a book down here, another there, and flip gently through the pages. No need to hurry. After all, if we're talking about time, why not savor it? So let's ask, what exactly is time? Some say it's a river, flowing endlessly forward, carrying us along like leaves drifting downstream. Others call it an arrow, shot from the bow of the universe, never stopping, always moving ahead. And yet, science, quietly but insistently, tells us that time is more flexible, more mysterious than we might believe. Albert Einstein once invited us to look differently. He said, "Space and time are not separate threads, but one great fabric, woven together." He called it space-time. Can you picture it? Like a vast, endless quilt stretching across the cosmos, soft and smooth. Now imagine placing a heavy ball, a planet or a star, right in the middle of that quilt. The cloth bends, doesn't it? Curves inward around the weight. If space can bend, Einstein said, then so can time. And that's where our little adventure begins. But wait, let's pause here. I want you to picture something personal. Think of the longest line you've ever stood in. Maybe it was at the airport, maybe it was at the grocery store during the holiday rush. Remember how time seemed to slow down? 5 minutes felt like 50. And then think of a joyful moment. A party, a hug, a laugh with a friend. Didn't it pass too quickly, almost unfairly so? Time felt different, though the clock ticked at the same pace. What Einstein discovered is that time doesn't just feel different. It is different depending on where you are, how you move, and what gravity is doing around you. This is where things get playful. Imagine you're on a spaceship, darting close to the speed of light. For you, the minutes stretch calmly, each second sliding past like a lazy cloud. But for someone back on Earth, years might be racing by. You could leave as a young traveler, and when you return, your friends might be gray-haired, your city transformed, your home unrecognizable. That isn't fantasy, it's a real prediction of physics. It's called time dilation. And isn't that strange? To realize that time itself is not a universal rhythm, like a drumbeat we all follow together, but more like music played at different speeds depending on the listener. One person hears a waltz, another hears a lullaby. But then you might ask, if time can stretch and bend, could it actually loop back on itself? Could we truly step into the past? Here's where things get a little dreamy. The mathematics of Einstein's equations sometimes whisper yes. They suggest structures called wormholes, tiny tunnels through space-time, like secret passageways carved into the fabric of reality. One entrance might be here in your room, while the other could open into the distant past or the far future. I imagine it like an old wardrobe in a quiet attic. You open the door, expecting mothballs and coats, but instead you find yourself stepping into another century. Romantic, isn't it? But also dizzying. Scientists, of course, are cautious. Wormholes remain purely theoretical. They may collapse too quickly to be useful, like soap bubbles popping before you can touch them. And even if they could exist, stabilizing them might require something exotic, negative energy, a kind of fuel stranger than anything we've ever known. But I ask you, doesn't every great adventure begin with something strange? Let's step back for a moment, though, because the question of time travel isn't just about equations or physics. It's also about paradoxes. Imagine this: you travel back to yesterday. You arrive in your living room watching yourself brew a cup of tea. If you knock the cup out of your own hand, what happens? Do you change your past self's memory? Do you erase the very reason you wanted to travel back in the first place? This is called the grandfather paradox. What if someone went back far enough and changed something so important that it prevented them from being born? If that were possible, who traveled back in the first place? The mind reels, doesn't it? It's like trying to fold a piece of paper in on itself forever. Eventually, you just can't. And yet, some scientists suggest there might be a way around this problem. They say maybe the universe wouldn't allow such contradictions. Maybe the past is fixed, solid as stone. You could travel back, but no matter what you tried, your actions would simply fit into history as it already happened. Others dream of branching timelines, like rivers that split and flow into many directions. Change the past, they say, and you don't destroy your own history. You simply create a new one, a parallel world that spins off alongside ours. Which vision feels truer to you? A universe set in stone, or one that blossoms into infinite possibilities? As I sit here and talk with you, I think about how every moment we live is already a kind of time travel. Every memory is a journey backward, every dream a little trip forward. When you smell fresh bread and suddenly feel 6 years old again in your grandmother's kitchen, that's time travel of a gentler sort, don't you think? And when we imagine our future selves, older, wiser, maybe sipping tea on a quiet porch, that too is a kind of journey through time, built from hope and imagination. Science gives us equations and experiments, but life gives us these small, personal time machines, tucked into our senses and our hearts. Still, we circle back to the big question. Could we, with metal and engines and human ingenuity, truly build a vessel that carries us across centuries? Here's a thought. Perhaps we already know the answer, hidden in plain sight. Because in a way, astronauts aboard the International Space Station are time travelers. They orbit Earth at incredible speeds, and because of that, their clocks tick a tiny bit slower than ours on the ground. When they come back, they are a fraction of a second younger than they would have been if they had stayed at home. Not exactly stepping into the Jurassic Age or the year 3000, but it's a start. Proof, in a quiet way, that time can indeed be nudged. And maybe that's what science is, a series of nudges. Small steps toward the extraordinary. Now, let's turn to another question that often bubbles up when people talk about time travel. If it were possible, where are all the visitors from the future? It's a fair question, isn't it? If someone, somewhere, someday builds a time machine, why don't we see tourists from the year 10,000, wandering our streets, snapping photos of us with their dazzling future gadgets? Some say maybe they're here but in disguise, blending in, careful not to disturb the fragile threads of our history. Others say maybe time travel only works forward from the moment it's invented. Like opening a door, you can walk through it into the next room, but you can't use it to visit rooms that were locked long before the door was built. Or maybe, just maybe, the reason we don't see time travelers is that the universe itself guards its secrets. Like a book that only lets you read its pages in order, one after another, never skipping ahead. And yet, I can't help but wonder, what if we are the time travelers? Not with machines, not with wormholes, but with curiosity, with imagination. Every time you ask a question about the past, every time you dream about the future, you stretch yourself across time in ways no clock can measure. Maybe that's the gift of being human. So, my friend, as we sit together in this gentle conversation, let's not rush to answers. Time travel is a question that lingers, like a candle's flame flickering in the dark. It invites us to slow down, to breathe, to imagine. And whether the universe ever opens its hidden doors or not, we can still find wonder in the mystery. We can still look at the stars and feel, in our bones, that time is more than just a clock's ticking. It is vast, elastic, shimmering, a fabric we have only begun to touch. So I leave you with this question. If a doorway through time appeared before you tonight, glowing softly in the corner of your room, would you step through? Or would you stay right here, savoring this moment, in the quiet company of a question that may never be fully answered? Sleep well, dear traveler. For in dreams, at least, time is always ours to explore. What does it mean when we say that time bends? If time is the thread, then what hand is holding the needle that curves it? And if space itself can fold and ripple, what strange shapes might it take? The kind that allow us not just to drift into tomorrow, but perhaps to glance backward into yesterday. Let's linger here with that thought, as if holding a fragile snow globe in our hands. Turn it gently, let the flakes fall, and imagine. Somewhere in the depths of the cosmos, there may be natural gateways to another when black holes. The very name sends a shiver down the spine. They sound frightening, don't they? Like traps, like cosmic monsters. But what if, just maybe, they are also the closest thing we have to a time machine? Think of a black hole as a great whirlpool in the ocean of spacetime. Stars, planets, even light itself can be dragged toward its center. And as something falls in, time stretches. Seconds for the falling traveler pass normally tick, tick, tick. But for an observer watching from afar, those same seconds stretch longer and longer, until it seems that the traveler has frozen at the edge, forever hovering at the brink. Isn't that curious? To one person, the fall takes only moments. To another, it looks eternal. Both are true, and yet, neither fully captures reality. This is where black holes whisper their strange secret. Time near them flows differently than it does far away. Gravity, so strong and heavy, pulls on time as if it were taffy. And the closer you get to the edge, the event horizon, the slower your clock ticks compared to the rest of the universe. So let's imagine this together. You, in a sturdy spacecraft, decide to orbit a black hole. Not too close, not close enough to cross the point of no return. Just close enough to feel the drag of spacetime stretching around you. You circle once, twice, maybe 10 times, and then you pull away, returning to safer cosmic seas. What would you find upon your return? For you, perhaps only hours or days have passed. But for the rest of the universe, your home, your planet, your friends, decades, centuries, even millennia might have slipped by. You would be a traveler into the future, without ever leaving your seat. Would you call that time travel? I would. And yet, it feels lonely too, doesn't it? To return and find yourself a stranger in your own world. Everyone you knew would be gone. Every story rewritten. Every familiar street changed into something unrecognizable. Time would have carried them forward without you, leaving you as a ghost of the past. A time traveler, yes, but one without a home to return to. This is the bittersweet nature of black hole time machines. They can carry you forward, but never back. A one-way ticket to tomorrow with no return. But what if there were something gentler, less devouring than a black hole? Enter the dream of wormholes. Picture two distant points in space. Let's say Earth and a star on the far side of the galaxy. Normally, the journey between them would take thousands, even millions of years. But what if, instead of walking the long road, you could fold the paper? Imagine space as a sheet. Place your finger on one end and your thumb on the other. The distance between them seems vast, but fold the sheet, bring the 2 points together, and suddenly your finger and thumb touch. A wormhole is that fold, a tunnel connecting two faraway places. In theory, you step into one mouth and emerge instantly from the other, bypassing the distance in between. Now here's where it gets even stranger. If you could manipulate the two ends of a wormhole, move one close to a black hole, or accelerate it at near light speed, time at one end would slow down compared to the other. When you step through, you might not just travel across space but also across time. Can you picture it? Enter the tunnel in your own century, and emerge into the age of pyramids, or into some glittering future. The wormhole becomes not just a bridge, but a clock. One that you can set in strange and wondrous ways. It sounds fantastical, doesn't it? And scientists will quickly remind us, wormholes are delicate, unstable things. They may snap shut before anyone can pass through. They may require exotic matter with negative energy to hold them open, and we've never truly seen such a thing. But isn't it comforting, in a way, that the universe allows the math for them at all? That our equations don't immediately forbid them, but instead leave the door just slightly ajar, as if inviting us to dream? So we return again to the question, if these things are possible, even in theory, why do we not see the footprints of time travelers? Perhaps wormholes, even if real, are too unstable. Perhaps black holes, though majestic, are too dangerous. Perhaps the cost is too great. Or perhaps, and here's a thought, maybe the universe has already woven its rules to protect itself. Maybe the very laws of physics act like a guardian, ensuring that no paradox is ever born, no timeline ever fractured. If so, then black holes and wormholes are not broken promises. They are mysteries placed like stars in the sky, visible, tempting, but unreachable for now. And yet, I find myself asking, would it be so bad if time travel remained a dream? Think about this. Every sunrise is already a journey into a future we cannot predict. Every memory we carry is already a bridge to a past that still lives within us. And the present moment, this heartbeat, this breath, is a miracle of balance, suspended between what has been and what will be. Do we truly need machines to travel through time, when our minds already do it so beautifully? But then, perhaps curiosity is its own kind of gravity, pulling us ever forward. We ask because we cannot help but ask. We imagine wormholes not because we expect to find them tomorrow, but because imagining them teaches us something about ourselves. That we are restless, that we are dreamers, that we refuse to let the river of time carry us without at least wondering if we can swim upstream. Now, let's circle back to black holes for a moment. They are not only possible gateways to time, they are also reminders of limits. Cross the event horizon, and no message can ever escape. For the traveler, it may feel like passing calmly onward, but for the rest of the universe, you have vanished. Is that, in itself, not a kind of time travel? To exist beyond reach, beyond story, beyond all clocks but your own? I wonder what it would feel like to step across that boundary. Would it feel like a fall or like floating? Would time stretch into infinity or collapse into nothing? No one knows. Perhaps no one ever will. And yet, isn't that the essence of wonder, that some doors are forever closed, and we stand outside imagining what might lie within? As I think about wormholes again, I picture them not as tunnels of physics but as tunnels of thought. Every time you ask, what if? You are digging a wormhole in your mind. One end planted here in the reality you know, and the other end opening into the landscape of imagination. You step through without needing exotic matter, without needing negative energy. You step through with nothing but curiosity. And when you emerge into visions of far futures or long past ages, you return with something precious. Not proof, perhaps, but perspective. So maybe the truest form of time travel isn't in equations or machines, but in the way we hold history in one hand and possibility in the other. But I ask you this, if one day humanity does discover a way to slip through a wormhole or orbit a black hole safely, who should decide how such a power is used? Would it belong to explorers, to governments, to dreamers? Or would it be guarded, hidden, too dangerous to share? And even deeper, if you had the chance to go, would you? Would you risk the paradox, the loneliness, the unmooring from your own age? Or would you stay here, grounded in the steady river of time as it flows naturally? I don't know the answer, but I think the question is worth keeping. And so, black holes and wormholes remain our guides tonight. They show us that time is not rigid, but soft. That the universe, far from being a clock that ticks coldly, is a fabric that bends and breathes. That within its folds, there may be hidden paths waiting for someone brave enough to look. For now, we look only with our minds. We drift into these possibilities like sailors gazing at the horizon, knowing we cannot yet cross it, but finding comfort in the thought that it exists. Time travel, then, is not only about machines. It is about wonder, about pausing in the night and asking, what if the universe has more doors than we think? And so, as we close this chapter, I leave you with a gentle question. If tomorrow, a wormhole opened in your room, one mouth glowing quietly beside your bed, and you could hear, faintly, the voices of another time echoing from its depths, would you step through? Or would you simply listen and let the mystery sing you to sleep? What happens when you try to fold a story back on itself? If a tale begins at point A, wanders to point B, and then suddenly loops back to A again, what becomes of the story? Does it repeat exactly word for word, step for step? Or does the very act of looping change the shape of what came before? This is the heart of the paradox of time travel. The puzzles that sprout like wildflowers the moment you even dare to imagine stepping into the past. So let's pause and ask, what if you could? What if tonight, without warning, you slipped into yesterday? Not in memory, not in imagination, but in reality. You walk into your own kitchen, and there you are, yesterday's version of you, stirring sugar into your tea. Do you say hello? Do you hide? Do you change something? And if you change it, what happens next? This thought experiment is called the grandfather paradox. The story is simple. Suppose you traveled back and prevented your grandfather from meeting your grandmother. What then? If he never met her, you would never be born. And if you were never born, who went back in time in the first place? It is a loop, tangled and stubborn, like trying to pull a thread from a knot that only tightens the harder you tug. But perhaps we should slow down here. Maybe we should ask a gentler question. Why does the mind recoil at these paradoxes? It's because time, as we live it, feels like a line. One thing follows another. You wake, you stretch, you eat, you walk. Cause leads to effect. To step backward along the line feels wrong. Like reading a book from the middle and discovering that the ending has already rewritten the beginning. But science, especially the strange mathematics of relativity, does not always forbid such loops. In fact, buried in the equations are solutions called closed time-like curves. Imagine a path through space-time that curls back into itself, like a snake biting its own tail. Travel far enough along the curve, and you end up not ahead, but behind, back where you started, yet carrying all the memories of the journey. Could such curves exist in our universe? Some physicists whisper maybe. They appear in the math near rotating black holes, in certain wild shapes of spacetime. They're like secret passages hidden in the geometry of the cosmos. But then the paradox strikes again. If such curves are real, wouldn't contradictions destroy them? Wouldn't the universe unravel the moment someone tried to step across their own timeline? Here's one possibility. Maybe the universe doesn't allow paradoxes. Maybe history is stubborn, unyielding. If you travel into the past, everything you do was already part of what happened. You knock the teacup from your younger self's hand, but perhaps you've always knocked it, and perhaps that's why you remember cleaning a broken cup yesterday. Nothing truly changes because the past is fixed. This is called the Novikov self-consistency principle. A mouthful, yes, but its meaning is simple. Time is consistent. No contradictions allowed. Does that sound comforting? Or does it feel like a cage? Comforting because it means no one could undo your existence. Caging because it means even if you had the power of time travel, you might be trapped in inevitability. And yet, others imagine a different answer. What if the universe is not one line, but many? What if every change births a new branch, a new timeline that grows alongside the old? This is the many worlds interpretation, a place where paradoxes dissolve, because there is no single history to damage. If you prevent your grandparents from meeting, you do not vanish. Instead, you leap onto a new branch of reality, where you were never born, but the original branch still exists untouched. So time travel doesn't break the story. It simply writes a new chapter. Isn't that a strangely hopeful idea? That every choice creates not just a consequence, but an entirely new universe, shimmering into being with its own skies, its own rivers, its own histories? And then, a question creeps in, if those universes exist, do we have a moral duty to them? If every decision spawns countless worlds, what responsibility do we carry for the lives that bloom from our choices? The paradox becomes not just a puzzle of logic, but a meditation on ethics, on possibility, on infinity itself. Let's linger on a simpler paradox for a moment, the bootstrap paradox. It asks, what if you went back and handed Shakespeare a copy of Hamlet? He copies it down, publishes it, and centuries later you grow up reading it in school. You travel back in time, inspired, and hand it to Shakespeare again. Where did the play come from? Who wrote it? It exists in a loop, without origin, without author. A gift passed endlessly between past and future, belonging to no one. Can you feel the eeriness of that? Like a ghost of an idea, unmoored from creation. Yet physics doesn't entirely forbid such loops. Energy, information, even an object itself could, in theory, be caught in this strange circle. And I wonder how much of our lives already feel like this. Stories retold so often we forget who first told them. Songs whose origins blur into the collective memory of culture. Aren't they, in a way, little bootstrap paradoxes of human history? But still, the mind protests. How can something exist without a beginning? Isn't that against the rules? And yet, the universe itself may be such a paradox. The cosmos has no clear beginning we can touch. We can trace back to the Big Bang, yes, but what was before? Did time itself begin there? Or is the universe a loop, folding endlessly upon itself? Perhaps paradoxes aren't mistakes. Perhaps they are clues, signposts pointing to places where our understanding falters, where deeper truths hide. Now, step with me into another question. If paradoxes make time travel so dangerous, does the universe protect itself? Some scientists suggest a principle called chronology protection. The idea is simple. Whenever conditions arise that might allow time loops, something, quantum effects, cosmic noise, intervenes to shut them down. Like a cosmic safety net, preventing paradox before it can sprout. If that's true, then maybe time travel into the past is forever forbidden. The doors are locked, the loops sealed, the story guarded. But if that's the case, why does the math still whisper otherwise? Why do Einstein's equations leave cracks where paradox might sneak through? Maybe because the universe likes to keep us guessing. And so we sit with these questions, caught between possibility and impossibility. Paradoxes are not answers, but mirrors, reflecting back our hunger to know. Do you feel it too, the tension between wonder and caution? The childlike thrill of imagining stepping into the past, and the adult hesitation that says, wait, what about the consequences? Maybe that's why time travel endures in our stories. It is less about building machines and more about exploring this tension in ourselves. The desire to revisit what's lost. The fear of breaking what we love. Think of the stories you've heard. Heroes trying to undo a tragedy, villains rewriting history for power, ordinary people longing to relive a perfect day. Each tale wrestles with paradox in its own way, sometimes with grim warnings, sometimes with playful twists. And beneath them all lies the same unspoken question. If you could change time, should you? Would it be right to erase mistakes if doing so also erases the lessons they taught? Would it be kind to save one person if doing so alters the lives of countless others in ways you can never predict? This is why paradoxes haunt us. They are not just puzzles of physics, but dilemmas of the heart. And so, perhaps, the universe is wise to keep its doors closed for now. But here's a softer thought. Maybe paradoxes are not warnings at all. Maybe they are invitations. Invitations to rethink what we mean by time, by cause, by story. Maybe the problem is not that paradoxes are impossible, but that we are not yet ready to understand how they fit into the grand tapestry. After all, for centuries, people thought heavier objects must fall faster than lighter ones. It seemed obvious. It seemed unquestionable. Until Galileo dropped his weights and proved otherwise. Perhaps one day, a future scientist will untangle the knot of paradox with the same simplicity, revealing that what we thought impossible was merely misunderstood. Until then, the paradoxes remain our bedtime companions. Strange, unsettling, but oddly comforting. They remind us that even the brightest minds have questions without answers. They remind us that the universe is bigger than our certainty. And so, as we let these thoughts drift like smoke into the night, I ask you one last question. If you held the power to step backward, into yesterday, into last year, into some century long gone, what would you do? Would you change something? Would you try to mend what feels broken? Or would you simply watch, quietly, letting history unfold as it always has, content to be a guest in its story? The paradox does not give you an answer. It only leans close and whispers, be careful what you wish for. And maybe that is enough. What does it feel like to chase the speed of light? Would the stars blur into streaks of silver, like raindrops sliding across a window? Would your heartbeat slow, each thump stretching out as though the universe were pulling it on invisible strings? Or would you simply sit there, sipping tea in your spaceship, feeling normal while everything outside of you changed? Time travel through speed is not the wild fantasy of wormholes or paradoxes. It is something quieter, simpler, and yet no less astonishing. It is the strange gift Einstein left us, tucked into the folds of his theory of relativity. The idea that time itself does not tick the same for everyone. So let us wander together into this question. If you could build a ship and push it ever faster, closer and closer to light's own pace, what would become of time? Imagine two clocks. One rests on Earth, ticking calmly in a sunlit kitchen. The other rides with you on your spacecraft, hurtling through the darkness. At first, the difference is invisible, imperceptible. Both clocks tick, tick, tick in harmony. But as your ship speeds up, half the speed of light, 3/4, 99%, something subtle begins to unfold. Your clock ticks slower. Your minutes stretch longer. To you, everything feels normal. You yawn, you stretch, you glance at your watch, and the seconds are steady. But if someone back home could see your clock, they would shake their head in wonder. You are slowing down, they would say. Your time is lagging behind ours. This is time dilation, the slowing of time at high velocities. Not imagination, not illusion, but a real, measurable effect. Would you call that time travel? Perhaps you should. Because when you return home, you will not return to the same now you left. You will step out of your ship and discover that while you experienced only months or years, the Earth has spun through centuries. Children have grown, civilizations have risen and fallen, languages have shifted, the constellations themselves may look different in the night sky. To you, the journey felt short. To everyone else, it was an age. Isn't that the strangest thing? That you could travel into the future not with fantasy machines, but simply with speed? Now picture this more vividly. Suppose you are 20 years old when you board your ship. You set off at near light speed, traveling among the stars for 5 years of your own time. You return at 25, still young, still filled with energy. But Earth has aged 500 years. Every person you knew is gone. Your city is dust, your language ancient history. You step out of your ship and realize you are not home. You are a time traveler. How does that thought feel? Lonely, perhaps, or thrilling, or maybe both? Let's ask another question. Why does speed bend time? It comes from the way the universe guards its ultimate law, that nothing can move faster than light. Light is constant, untouchable. No matter how quickly you run toward it, no matter how desperately you chase it, it will always pull away from you at the same pace. 299,792 kilometers per second. So, the universe makes a bargain. You cannot catch light. Instead, time and space bend themselves to keep the balance. The faster you go, the slower your clock ticks, the shorter distances become in your direction of travel. Space contracts. Time dilates. In this way, the universe preserves its law, but offers you something extraordinary in return, the chance to step into another age. Would you dare to take it? Now, let's play with a thought experiment. Imagine twins. One stays on Earth, the other boards a near-light-speed ship. Off the traveling twin goes, zipping among the galaxies. Years pass for her, 10, maybe 20. When she returns, she is still young, her hair dark, her step light. But her sibling on Earth has lived far longer, perhaps grown old, perhaps gone entirely. This is the twin paradox. Paradox not of contradiction, but of feeling. For it is no trick, this effect is real. Astronauts in orbit, moving swiftly around Earth, already experience time passing ever so slightly slower for them. When they return, they are nanoseconds younger than they would otherwise have been. Tiny, yes, but proof. Proof that time is not rigid. And so the paradox is not really a paradox at all. It is simply the price of speed. Now imagine taking it further. Not nanoseconds, but centuries. Not just a hair's breadth of time, but vast gulfs of history slipping past like waves. Would humanity, then, build ships not for exploration of space but of time? Picture a civilization sending voyagers into the stars, knowing that when they return, they will bring back not news of distant planets, but news of the future of their own world. They would be scouts of time, not place. What role would such travelers play? Would they be historians, gazing back at a world that no longer exists? Or prophets, carrying the past into a world too young to remember it? Perhaps they would be both ghosts and guides at once. And here comes another question. If you could leap forward this way, would you want to? To skip the long wait, to see what becomes of humanity, to meet your descendants, or the cities that rise from your own home's ruins? Or would you fear what you might find? That the world you knew is gone, replaced by something unrecognizable? Time travel forward may be possible, but it is not without cost. Because isn't part of the beauty of life the way we grow into our futures slowly, day by day? Would leaping ahead feel like tearing pages from a book, missing all the subtle threads that connect one chapter to the next? And yet, the lure remains. To sail at light's edge is to step into a grand experiment. A ship not only through space, but through centuries. Now let's linger on the physics a little more gently. Think of spacetime as a great fabric, stretched tight. When you are at rest, you move mostly through time, barely through space. You age at the normal rate, but as you speed up, you begin to trade time for space. You move faster through space and slower through time. The fabric balances the two like a seesaw. More of one means less of the other. Isn't that a poetic thought? That we each have a kind of budget of motion through spacetime. At rest, you spend it all on time. At high speed, you save it for space and time trickles more slowly. Cosmic currency, shared by all. And the speed of light? That is the limit, the point at which your entire budget is spent on space, leaving none for time. You become frozen, timeless, a beam of light itself. From its perspective, it never moves. It leaves a star and arrives at your eye instantly, no time passing at all. Can you feel the strangeness of that? That light has no sense of journey, only of being? Perhaps, in chasing light, we are not just reaching for speed, we are reaching for timelessness, for eternity. But eternity is not for us. Not yet. We are bound to slower journeys, to clocks that tick. And maybe that is not a curse, but a gift. Because if time did not move for us, would we savor the present as we do? Would we cherish moments knowing they will pass? Still, the dream persists. Humanity has always longed to outrun time. And in relativity, we see not just a fantasy, but a door slightly open. So what holds us back? The answer is energy. To accelerate a ship close to light speed requires unimaginable power. Each fraction closer to light demands exponentially more energy, like climbing a mountain that grows taller with every step. To reach the summit may be impossible with the tools we know, but perhaps the future will hold engines we cannot yet imagine. Or perhaps, like so many things, the journey will be less about reaching the summit and more about learning what lies along the way. For now, time dilation lives mostly in thought experiments and tiny demonstrations with orbiting satellites. But even in these small ways, it teaches us something profound. That time is not absolute. That each of us carries our own rhythm of existence, tied to where we are and how we move. And doesn't that, in its own way, make life richer? So tonight, let's leave ourselves with this picture. A lone ship sails between the stars, its engines humming softly. Inside, the traveler writes in a journal, not knowing that each word she writes is being carried centuries ahead of its birth. She does not feel herself as extraordinary, only as a person moving forward in time as we all do. But when she returns, her words will be relics, her memories artifacts of a world long gone. She will be proof that time is not what we thought it was, that speed can stretch the river and let us step onto its banks. And I ask you as we close, if such a ship waited for you, its door open, its engines ready to carry you into the centuries ahead, would you climb aboard? Or would you stay here, in the gentle unfolding of your own time, content with the mystery of not knowing what tomorrow holds? Either way, the question remains, glowing quietly in the dark. Is time something we can master, or only something we can marvel at? Why does time only flow one way? Why do we wake each morning to find ourselves older, never younger? Why do the broken cups on the floor never leap back onto the table, whole again? If time can bend and stretch and dilate, if it can be twisted by speed and gravity, why does it seem so stubbornly determined to march forward? This is the riddle of the arrow of time. Imagine holding a deck of cards. You drop them, and they scatter messily across the floor. Easy, natural. But try the reverse. Watching scattered cards suddenly leap up, organize themselves into a neat deck, and land back in your hand. It feels impossible. And yet, the laws of physics, written on the chalkboards of our scientists, do not forbid it. The equations work just as well forward as they do backward. So why, then, does reality choose forward? Perhaps the answer lies in entropy. Entropy is a soft, intimidating word. It whispers of disorder, of things falling apart. It is the tendency of systems to move from order into chaos, from neat stacks into messy piles, from shining youth into weathered age. Can you feel it in your own life? The way the room slowly gathers dust. The way heat from your coffee always fades into the cool air, never the other way around. Entropy is the slow drift of the universe toward randomness. And entropy, some say, is the true keeper of time's arrow. Think of the universe as a great library. In the beginning, the books are stacked neatly, every volume in its place. But as time passes, the shelves grow messy. Books are pulled out, left open, misplaced. Order fades into disorder. And though you might tidy a shelf here and there, the library as a whole tends toward chaos. This is why time feels like it moves forward. Not because the laws of physics demand it, but because entropy grows. Isn't it strange? That the march of time may not be a grand cosmic decree, but simply the universe's tendency toward messiness. But here's a softer question. Does entropy explain everything? Or is there something more? Let's imagine rewinding the universe. Stars unburning, galaxies collapsing inward, dust clouds reforming into neat beginnings. Eventually, we would arrive at the Big Bang itself, an unimaginably hot, dense state. The most orderly, the most low-entropy moment of all. Why was the universe born that way? Why did it begin so tidy, so structured, when the natural tendency is toward chaos? No one knows. Some call it a mystery, perhaps the greatest of all. Without that low-entropy beginning, there would be no arrow of time. No before and after. No growing older. No stories to tell. Do you see what that means? The very fact that we can remember the past but not the future may be written into the first moments of the universe. Time's arrow carved into existence at the very beginning. But then another question. Could there be places where the arrow of time runs differently? Some theories whisper that in black holes, or at the edge of the universe, time might not behave as we know it. That entropy might flow differently or even reverse. Could there be pockets of reality where broken cups really do leap back together? Where rivers run uphill, where memory itself feels backward? Would you want to visit such a place? To see time reversed? Or would it feel too uncanny, too alien to bear? Entropy doesn't just shape our world in abstract ways. It shapes our lives, our bodies, our stories. Think of a childhood bedroom. Bright toys, scattered crayons, the smell of new paper. Now think of that same room years later. Dust in the corners, posters faded, boxes stacked in storage. The entropy of life, the drift of time. And yet, in that entropy, isn't there also beauty? The wrinkled hand that once held yours tells a story of decades. The faded photo carries the warmth of memory. Entropy is not only loss, it is also history. It is what allows us to tell a story at all. Without time's arrow, every moment would be frozen, indistinguishable from the next. No change, no growth, no life. So perhaps we should not mourn entropy too quickly. Perhaps it is the very fabric of meaning. But still, I wonder, could we ever defy it? Scientists dream of machines to fight entropy. Refrigerators that keep food from spoiling, air conditioners that push heat back into order. But of course, these machines only work locally. They reduce entropy in one place while increasing it elsewhere. A tidy kitchen is bought at the cost of energy burned, of fuel spent, of heat released. The universe as a whole always pays its price. Could we one day cheat the whole system? Or is the arrow of time too deeply written, too eternal? Here is another way to ask the question. What if memory itself is the child of entropy? We remember the past, not the future, because the past is more ordered. Our brains lay down patterns in the ordered structure of yesterday. The future, by contrast, is the realm of entropy, of uncertainty, of disorder still waiting to bloom. So perhaps memory is proof of entropy's power. We do not walk forward in time. We are carried by the tide of increasing disorder, our memories the flotsam left behind on the shore. Isn't that humbling? That even our most personal treasures, our memories, our stories, might be entangled with the same principle that scatters dust and fades stars. Now let's ask a wilder question. What if entropy stopped? Imagine waking tomorrow to find that time no longer moved forward. Your tea stayed hot, forever steaming. Your hair never grew. Your books remained crisp and new. No dust gathered, no wrinkles formed. At first, it might feel like paradise. Eternal youth, eternal freshness. But then, wouldn't it also feel lifeless? No change, no surprise, no story. Just a static eternity. Would you trade the sweetness of change for the stillness of forever? Perhaps entropy is not the enemy. Perhaps it is the brushstroke that paints our lives with texture, with depth. Without it, there is no journey. Only a picture, frozen and mute. And yet, entropy has its darker face too. Stars burn out, galaxies thin, and the universe itself drifts toward what scientists call heat death. A time when all differences have evened out, all order dissolved into uniform grayness. No stars, no life, no stories. Only stillness. Doesn't that thought weigh heavy? That the arrow of time might carry everything not just forward, but toward an ending? But wait, should we despair? Perhaps not. Because even if the far future is quiet, the present is vibrant. The universe, right now, is alive with stars, with rivers, with laughter. Time's arrow gives us today, even if it also points toward tomorrow's silence. And who knows, maybe new physics awaits, physics we cannot yet imagine, that reshapes the fate of time itself. Maybe entropy is not the whole story. Until then, we are left with this paradoxical truth. Time flows forward not because of some cosmic command, but because disorder grows. Because entropy whispers onward. And yet, in that onward flow, we find meaning. We write poems. We sing songs. We fall in love. We watch children grow. We remember. Entropy gives us sorrow, yes, but it also gives us story. So let's ask one last question. If you could step outside of time's arrow, just for a moment, would you? Would you pause the drift of entropy, hold the world still, and savor one perfect instant forever? Or would you, like a leaf on the river, let yourself be carried forward, embracing the change, the loss, the beauty of becoming? Perhaps the answer lies not in fighting entropy, but in walking with it. Perhaps the arrow of time, sharp though it may seem, is not a weapon against us but a compass, pointing us always toward the next chapter of our story. And isn't that, in its own way, a kind of time travel? What does time look like when you shrink yourself down, smaller, smaller still, until you are no bigger than an atom? Does the arrow of time still march forward, steady and certain? Or does it wobble, flicker, perhaps even vanish in the strange dance of the quantum world? This is the riddle of quantum time. In the everyday world, time feels reliable. Your clock ticks. Your tea grows cold. Shadows stretch across the floor as the sun moves in the sky. Cause and effect follow one another like links in a chain. But in the quantum world, the world of electrons, photons, and the tiniest particles, rules seem less like chains and more like dice tossed across a table. Here, particles do not travel in neat lines. They shimmer in probabilities. They may be here or there or both. They may spin clockwise, counterclockwise, or in a ghostly blend of the two. And sometimes, just by looking, you change what they decide to be. So, if the building blocks of reality behave this way, what does it mean for time? Let's ask slowly. Imagine a particle traveling from one place to another. In the classical, everyday world, it takes a path. A straight line, perhaps, or a curve. Time flows as the particle moves. Simple. But in the quantum world, the particle does not take one path, it takes all possible paths. Every curve, every zigzag, every loop is traced in a vast, shimmering web. Only when you measure it, only when you look, does it collapse into a single outcome. What happened to time along those ghostly paths? Did it flow forward in every one? Did some flow backward? Did time itself split into possibilities, just as the particle did? Some physicists suggest yes, that the quantum realm does not honor the same arrow of time we know. That at this tiny scale, the laws of physics work equally well backward as forward, and time may not prefer a direction at all. Isn't that unsettling? That the arrow which seems so sharp in our world may blur at the smallest levels? And yet, perhaps it is not unsettling. Perhaps it is simply a reminder that time, like so many things, depends on perspective. Think of a forest. From far above, you see the trees forming a pattern, the river winding through, the seasons changing year by year. But step closer still, down to the moss, down to the soil, down to the roots, and the picture is different. Movement is slower, stranger, harder to see. The great pattern dissolves into tiny mysteries. Maybe time is like that. On the human scale, the forest is clear. On the quantum scale, it becomes mist. But if time is mist at the quantum level, what does that mean for us, creatures built entirely out of quantum particles? Could it mean that our sense of past and future is not absolute, but emergent, like the way a flock of birds moves together even though no single bird knows the pattern? Perhaps time, as we know it, is not a fundamental law, but a story told by the collective dance of particles. Now, here is another question. Do quantum particles remember? In the classical world, memory belongs to us, to brains, to records scratched into books and stones. But in the quantum world, a particle may interact with another, and even if they drift apart across light years, their states remain mysteriously linked. This is called entanglement. Imagine two dice rolled together, then separated. One lands on the moon, the other stays on Earth. You throw the Earth die into the air, and it lands on a 6. At that instant, the moon die, no matter how far away, knows to land on a 6 as well. Entanglement does not respect distance. It does not wait for signals to travel. It simply is. But what does that mean for time? If entangled particles share a state instantly, across any distance, does that mean time between them is meaningless? That their now is the same even across galaxies? Some whisper that entanglement might hint at a deeper layer of reality, one where time and space themselves are not fundamental, but emerge from something more primal, something outside our usual sense of before and after. Wouldn't that mean time, as we know it, is not the bedrock of the universe, but only a ripple upon it? And here is the most unsettling question of all. If the quantum world does not respect time's arrow, then why does the macroscopic world, the world of trees and rivers and you and me, obey it so strictly? Why is there such a gap between the timeless quantum realm and the orderly flow of our daily lives? One answer is decoherence. At the quantum level, particles exist in delicate superpositions, this and that, here and there, forward and backward. But when they interact with their environment, when they touch air molecules or photons or our clumsy measuring devices, these superpositions collapse. Possibilities fade, and a single outcome remains. Decoherence may be the bridge between the quantum mist and the classical arrow. The moment a system becomes large enough, tangled enough, its strange quantum timelessness collapses into the familiar forward march. Isn't that curious? That the arrow of time may not come from fundamental laws, but from the act of entanglement with the world. That our universe may be timeless at its core, and only gains its forward flow as complexity grows? If that is true, then perhaps we are time's makers. Not by intention, but by existence. By being large, messy, entangled creatures, we collapse the quantum mist into the ordered arrow. We give time its direction simply by living. Isn't that a comforting thought? That our very presence may help carve time's shape? And yet, it raises another puzzle. If quantum mechanics allows time to flow both ways, does that mean the future can influence the past? Some interpretations whisper yes. They suggest that particles may not only be shaped by where they have been, but also by where they are going. That the outcome of a quantum experiment may be influenced by a measurement made later. This is called retrocausality, a word as eerie as the concept itself. Imagine flipping a coin today and discovering that the outcome was influenced by a choice you will make tomorrow. Imagine writing a letter and realizing its words were guided by the person who will read it in the future. Could that be true? Could causality itself, our bedrock belief that the past shapes the future, be only one way of looking at things? And if so, what becomes of free will? What becomes of responsibility? Perhaps, though, we should not leap to conclusions. Perhaps retrocausality is not so much about rewriting history as it is about the deep interconnectedness of events, past and future woven together in ways we do not yet understand. Still, it leaves us with wonder. Could the present moment be a meeting point, shaped not only by the echoes of the past but also by whispers from the future? And if so, could that mean time is less like a line and more like a tapestry, threads woven in both directions, forming a pattern only visible when seen as a whole? Pause for a moment and imagine that tapestry. Bright threads of memory stretching back, threads of possibility reaching forward, all interlacing in a fabric so vast we cannot see its edges. From where we sit, the weave looks like a simple arrow. But from a higher view, perhaps from the universe's own perspective, it is timeless, a whole picture complete in itself. Doesn't that image feel strangely peaceful? Quantum mechanics often feels chaotic, wild, ungraspable. But maybe, beneath its haze, it hides a harmony where time is not broken, but whole, where past and future are not enemies, but companions, holding hands in the dance of existence. And here we return to our quiet question. What is time? On the quantum scale, it may be an illusion. On the human scale, it is a river. On the cosmic scale, perhaps it is a tapestry. Each scale reveals a different truth, none complete, all mysterious. So where does that leave us? It leaves us here, in this present moment, suspended between what has been and what will be. A creature of the quantum world, yet bound to the arrow of entropy. A traveler in time not by machines, but by simply being alive. And maybe, just maybe, the quantum world teaches us a lesson. That time is not to be feared, or controlled, or mastered. That time is not a single line, but a shimmering mist of possibilities. That what feels solid may be soft, and what feels certain may be open. So, let me ask you, if you could hold the universe in your palm, shrink it down to the size of a particle, and watch time behave in its quantum strangeness, would you? Would you want to see moments flowing both forward and backward, futures shaping pasts, possibilities blending and collapsing? Or would you find comfort instead in the steady tick of your clock, in the arrow that carries you gently forward, one heartbeat at a time? Perhaps both are needed, the quantum mist and the arrow's march. Together they form the mystery of our days. And perhaps that is enough. What is a moment? Is it the flicker of a second hand, the blink of an eye, the pause between two breaths? Or is it something softer, less measurable, like the feeling of sunlight on your skin, or the way a memory lingers long after the instant has passed? If time is a river, memory is the boat we ride upon it. But what if memory does more than simply carry us along? What if memory is the very reason we feel time at all? Let's ask carefully. Why do we remember the past but not the future? Why does yesterday leave its footprints so clearly in our minds, while tomorrow is always a blank sheet? Some scientists whisper that memory and time are woven together more tightly than we realize. That our sense of the arrow of time, the feeling of moving forward, may come not from clocks or physics, but from the way our brains write their stories. Think of memory as a kind of time machine. Close your eyes and recall your first day of school, or the smell of your grandmother's cooking, or the sound of rain on a childhood window. For a moment, you are there. The present room fades. The past sharpens. The years collapse into nothing. Isn't that a journey through time? Not with metal ships or wormholes, but with neurons and chemistry. But here's the curious part. Memory is not a recording. It is not a film strip you play back, frame by frame. Memory is more like a painting, rebuilt each time you summon it, brushstrokes laid down again and again, altered by your present mood, your present knowledge, your present self. So when you travel backward in memory, are you visiting the past? Or are you creating a new past, stitched together by imagination and truth? That thought can feel unsettling. But maybe it is also beautiful. Because if memory is a painting, then every recollection is alive. Each time you revisit a moment, you give it new color, new breath. Isn't that, in its own way, a gift? Now let's turn the question around. If memory lets us travel backward, what lets us travel forward? That would be imagination, the ability to picture what is not yet real. To anticipate tomorrow's breakfast, next year's journey, or a distant dream. Neuroscientists have discovered something wondrous. The same parts of the brain that recall the past are also used to imagine the future. Memory and foresight are twins, born of the same circuits. When you remember, you build. When you imagine, you build. The process is nearly the same. So perhaps we are all time travelers already, moving backward with memory, forward with imagination, endlessly weaving our lives from these threads. But then, here is a deeper question. If our memories are imperfect paintings, what does that mean for the arrow of time we feel so strongly? Could it be that the sense of time flowing forward is not an objective truth, but a story told by memory itself? That we move through life not because time demands it, but because our brains collect footprints behind us and leave the path ahead blank? What if the future feels empty not because it doesn't exist, but because we cannot remember it? Pause with that thought for a moment. Let it sink in like ink on paper. The arrow of time might be less about physics and more about perception. Of course, physics still has its laws. Entropy still grows, clocks still tick, stars still age. But the way we experience time, the way it feels, might be painted by memory's hand. And that hand is fragile. Memory slips, fades, distorts. The stories we tell ourselves are sometimes untrue. We forget, we confuse, we replace. Does that mean time itself is fragile too? Or just our window into it? Think of dreams. In a dream, time bends strangely. Hours can pass in minutes. Entire lifetimes can be lived before you wake. And when you do, the memory dissolves like mist, leaving you with only fragments. What does that say about time? Or about the mind that perceives it? Maybe dreams are a reminder that time, for us, is not just physics. It is also psychology. It is not only measured by clocks, but also by feelings, by rhythms of thought, by the way neurons fire in the dark. And isn't it curious how subjective time feels? A dull meeting stretches forever, while a joyful conversation vanishes too soon. A child's summer feels endless, while an adult's year vanishes in the blink of an eye. What if this subjectivity is not just illusion? What if it is part of the truth of time, that it is not one universal rhythm but many melodies played at once? Memory, then, is not just about the past. It is about the very shape of time itself. Now let's wander into another question. What happens when memory is damaged? For those who lose their ability to form new memories, time seems to fracture. They live in a perpetual present, unable to move forward. Their arrow of time stalls. Their life becomes an endless loop of now. Isn't that tragic? But also illuminating. Without memory, the flow of time itself seems to vanish. So maybe memory is not only a time machine, it is the engine of time as we know it. Without it, the river becomes a still pond. And yet, memory is not just personal. We build collective memories too. History is humanity's great time machine. We write books, carve stones, record voices, paint canvases. Each is a way of preserving moments, of keeping yesterday alive. And history, too, is imperfect, biased, selective, rewritten by those who tell it. But still, it gives us a sense of direction. It anchors us in the flow. What, then, is the future but collective imagination? Plans, predictions, hopes. Cities drawn on blueprints. Stories told around fires. Futures imagined, waiting to be born. Together, memory and imagination shape the great arrow of human time. Now let me ask you, if you could remember the future as easily as you remember the past, how would life feel? Would you find it comforting, knowing every step before you take it? Or suffocating, unable to change the path? Perhaps the blankness of the future is what gives us freedom. Perhaps forgetting what has not yet happened is the very thing that allows choice, hope, surprise. So memory, imperfect though it is, may be a blessing. It limits us to one direction. It makes us creatures of narrative, of growth, of becoming. But here is another puzzle. If memory is reconstructed every time we recall it, then in a sense, each act of remembering is also an act of rewriting. Isn't that like time travel? Each time you revisit the past, you alter it slightly, at least in your own mind. The memory you carry tomorrow is not quite the same as the one you carried yesterday. And so the past, too, is not fixed, not in our minds. It shifts, it bends, it evolves. That thought may feel unsettling, but perhaps it is also freeing. If memory were perfect, unchanging, absolute, would we not be trapped in it? Would the pain of yesterday never soften? Would mistakes never blur with forgiveness? Our imperfect memory allows us to heal, to grow, to retell the story in gentler ways. So maybe time is not just physics, not just entropy or relativity. Maybe time is story. The story we tell ourselves about who we were, who we are, and who we might yet become. And in that story, memory is both the ink and the editor. It records, but it also revises. It anchors, but it also frees. Which leaves us with this final question tonight. What do you want to remember? Because in the end, memory is not infinite. It is selective, fragile. We cannot keep everything. The river carries most things away, but some memories we choose to hold. A smile, kindness, a moment of beauty, and those chosen memories shape our sense of time more than clocks ever could. So, if time is the river, memory is the boat, but you are the one who decides which cargo to carry. Would you carry regrets, heavy and sharp? Or would you carry joys, light and shining, to guide you forward? Perhaps that is the truest form of time travel we have. The ability to choose what we remember, and in doing so, to shape the story of our lives. What did the ancients think time was? Was it a god, a circle, a river, or a relentless force that spared no one? Before equations, before telescopes, before atomic clocks, humanity had only stories, myths, and rhythms to understand the strange flow of existence. And perhaps those stories still whisper truths, even now. Imagine standing thousands of years ago, with no watch on your wrist, no calendar on your wall. The sky is your only clock. The sun rises, the sun falls. The moon waxes and wanes. Seasons come, seasons go. Time is written not in numbers but in light and shadow, in the growth of crops, in the lines of a face. Would time feel slower then? Or would it feel more alive, woven into the cycles of nature, less a measurement, more a presence? Let's wander gently through the myths of time. In ancient Greece, time was not one thing but many. There was Chronos, the god of sequential, measurable time, the ticking, linear march we know so well. But there was also Kairos, the god of the opportune moment, the perfect instant when something could change forever. One is quantity, the other quality. Can you feel the difference? Chronos is the minutes that drip steadily, like water from a leaky faucet. Kairos is the sudden, golden chance. A kiss, a revelation, a turning point. Which one, I wonder, feels more like the time we truly live in? Then there is the image of Chronos devouring his children. A dark reminder that time consumes all things. Nothing escapes. Not gods, not heroes, not even stories. Time is both creator and destroyer. But in Hindu philosophy, time is something else entirely. It is kala, vast and cyclical. The universe is born, grows, dissolves, and is born again in endless cycles, like the breath of a cosmic being. Time is not an arrow but a wheel so vast that even the ages of civilizations are but single rotations. Isn't that a comforting thought in some way? That even destruction is not final, but only part of a cycle. That endings are seeds of beginnings? Buddhist thought adds another layer. Time, they say, is an illusion. The present is all there truly is. Past and future are but thoughts, shadows of the mind. To live fully is to let go of the grasping at before and after, and sink into the deep now. Have you ever felt that, even briefly? A moment so full, so vivid, that time seemed to disappear? Perhaps watching the sea, or listening to music, or holding someone's hand. For an instant, there is no clock, no arrow, only presence. And then there are the Norse myths. There, time is shaped by fate, woven by the Norns, three mysterious women who spin the threads of destiny. Past, present, and future are strands in their loom, knotted and tangled in ways no one can undo. Even the gods must obey the weaving of time. What does it mean to imagine time as a tapestry? Does it make it feel less frightening, knowing that our lives are threads in a pattern greater than ourselves? Or does it feel heavy to think that the weave cannot be changed? And let us not forget the Mayans, whose calendars did not just track days, but vast cycles stretching thousands of years. To them, time was sacred geometry, a pattern of repeating ages. Birth, flowering, decay, renewal. Each culture, each story paints time differently. A devouring god, a wheel, a river, tapestry, an illusion. Which one feels truest to you? Perhaps all of them hold a piece of the truth. Perhaps time is not one shape but many, depending on how you stand, how you look. But why did humans feel the need to give time a face, a story, a myth? Maybe because time is invisible yet inescapable. You cannot hold it, yet you feel it pressing on you. You cannot see it, yet it writes wrinkles on the skin and wears mountains down to sand. To make sense of something so intangible, we gave it voices and symbols. We clothed it in story so that we might speak with it, negotiate with it, fear it, even love it. And maybe we still do. Isn't our modern talk of time, deadlines, timelines, lifelines, just another mythology dressed in clocks instead of gods? Think about how cultures mark time. Some see it as linear progress, a road from primitive to modern, from past to future. Others see it as cyclical, a wheel of repeating patterns. One gives us history, the other gives us ritual. Which is closer to reality? Do we march forward, never to return? Or do we circle endlessly, repeating themes like music refrains in a song? Look at your own life. Childhood, youth, maturity, old age. At first, it feels linear, you grow, you change. But look deeper, and you see cycles too. Waking and sleeping, eating and fasting, working and resting, grieving and healing. Within the line are circles. Within the circles, a line. Perhaps time is both. An arrow winding upon a wheel. And then there is eternity. Many cultures dream of it, fear it, or long for it. An existence beyond time, beyond change. But ask yourself, would you want eternity? Or does eternity, with no cycles, no endings, no stories, sound more like stillness than life? Maybe that is why so many myths speak of gods who envy humans. For though gods may be eternal, they cannot taste the sweetness of fleeting moments, the sharpness of loss, the beauty of impermanence. Would you trade your finite years for eternity? Or is the very limit of time what gives it meaning? And here is another thought. Every culture's story of time reflects not just the universe, but also their way of life. Farmers saw cycles, hunters saw seasons, kings saw lineages, mystics saw illusions. And today we see time as productivity, schedules, deadlines, because that is the myth of our age. So I ask you, what story of time do you carry? Is it the wheel, the arrow, the tapestry, the devouring god, or something else entirely? And more importantly, does the story you carry shape the way you live? If you believe time is a river, do you drift along? If you believe it is a wheel, do you wait for renewal? If you believe it is an arrow, do you rush forward, afraid to waste a moment? Perhaps the greatest power of these myths is not whether they are true, but how they guide our lives. Now imagine this. What if we could collect all the myths of time, from every culture, every era, and lay them side by side like stones in a mosaic? What picture would they form? Would it be a portrait of time itself? Or would it be a portrait of humanity? Our fears, our hopes, our longing to make sense of what carries us? Because in the end, myths are mirrors. They tell us less about the universe and more about ourselves. And perhaps that is the secret. That time is not just something out there, in the stars and the clocks. Time is also something in here, in the stories we tell to give it meaning. So when you hear the ticking of a clock, you are not just hearing seconds pass. You are hearing centuries of stories layered together. The gods, the cycles, the wheels, the arrows, all whispering inside that steady tick-tock. And when you close your eyes and imagine the future, or recall the past, you are stepping into the same river where ancient storytellers once stood, gazing at the same mystery. So let me ask you one last question for tonight. If you were asked to invent your own myth of time, what shape would it take? Would it be a spiral, always circling yet always climbing higher? Would it be a song with verses and refrains? Would it be a garden, blooming and fading with the seasons? And what would that story say about you? Because maybe, just maybe, the shape of time is not fixed at all. Maybe it is a story we each carry, weaving our own myth as we live, adding our thread to the endless fabric of human wonder. And perhaps that is enough. How old is the universe? When you look up at the stars, glittering in the night sky, are you gazing at youth or at ancient age? And when you whisper to yourself, how long has all this been here? What answer would satisfy you? Time, on a cosmic scale, is almost impossible to hold in the mind. Our human lives are measured in years, decades, at most a century or two. But stars and galaxies stretch across billions of years, ages so vast they seem almost beyond imagination. Yet we try. We always try. Think of the light of a star. The one you see tonight may have left its home thousands, even millions of years ago. The star itself might no longer exist, already gone to ashes, while its final light still travels across the void, arriving just now to your waiting eyes. Isn't that like a kind of time travel? That the night sky is not a picture of now, but a patchwork of whens, every star shining from a different moment in history, stitched together into the quilt we call tonight. What does that mean for us, small creatures standing under this ancient glow? Perhaps it means that the universe itself is a memory keeper, holding the past in beams of light, carrying it forward through time. Now, let us ask the bigger question. How old is everything? Cosmologists tell us the universe is about 13.8 billion years old. A number that sounds precise yet is so enormous it feels almost abstract. What does 13.8 billion years feel like? Let's try to scale it down. Imagine the history of the universe compressed into a single year, the famous cosmic calendar. In this calendar, the Big Bang happens at midnight on January 1st. Galaxies form by January 10th. Our Milky Way comes together in May. The Sun is born on September 1st, and Earth follows quickly after. Life begins in late September. Dinosaurs appear on December 25th, only to vanish by December 30th. And humanity? We arrive in the final seconds of December 31st, barely a flicker before midnight. Do you feel it now? How small, how brief our place in cosmic time truly is. And yet, how wondrous that we exist at all within this vast span. But let's not just recite ages. Let's walk through them slowly. The Big Bang. Not an explosion in space, but an expansion of space itself. Time and space emerging together, carrying energy, matter, and the seeds of everything we know. What was before? We do not know. Perhaps there was no before, because time itself began there. A few minutes later, the first atoms form hydrogen, helium. The universe cools, expands, darkens. For hundreds of millions of years, it is a vast sea of gas. Then the first stars ignite. Imagine it. Darkness pierced by the very first light, suns blazing in the cosmic night. These first stars burn hot and short, exploding into supernovae, scattering heavy elements into space. From their deaths, new stars form, richer, brighter, with planets circling them. The galaxies gather, pulled by gravity into clusters and swirls. The Milky Way, our home, is one among billions, born in this cosmic dance. Billions of years pass. The Earth forms, oceans appear, life stirs, and much, much later we come along, tiny beings on a small planet orbiting a modest star. And yet, somehow, we dare to ask the age of it all. Doesn't that feel astonishing? That the universe, after nearly 14 billion years of silent unfolding, has produced creatures who can measure its age, tell its story, and marvel at its mystery? But let's linger on a softer thought. If the universe is this old, where is it going? The cosmic arrow of time points not just from past to present, but onward, into futures as vast as its history. Stars will burn out. Galaxies will drift apart. Time on this scale is not just age, it is destiny. Already, scientists tell us the universe is expanding faster and faster, pulled outward by something called dark energy. Galaxies slip away from one another like ships drifting apart in the sea. Someday, far in the future, the night sky may grow emptier, its stars so distant their light will never reach us. Doesn't that thought feel lonely? That the universe we know is only temporary, a fleeting window filled with starlight? And yet, perhaps it is also precious, because it means we live in a moment of cosmic beauty, when the sky is still bright, when galaxies still shine, when the past is still visible in the stars. What is 13.8 billion years to you here in this quiet moment? It might feel overwhelming, too large to hold. But think of it this way. Every atom in your body is older than Earth itself. The carbon in your bones, the oxygen in your lungs, the iron in your blood. These were forged in the hearts of ancient stars, billions of years ago, before our sun was born. You are made of stardust, not as metaphor, but as fact. You carry cosmic history in every cell. Doesn't that make you a time traveler already? A creature who embodies billions of years of memory, condensed into the span of a single life? Now, let us ask another question. If the universe has a beginning, does it also have an end? Some theories say yes. Perhaps it will end in heat death, when entropy reaches its maximum, when all stars have burned out, when no differences remain. A still, cold universe, timeless and empty. Others suggest a big crunch, where expansion reverses, galaxies collapse together, and time itself folds back into a singularity. Still others whisper of cycles, the universe reborn again and again, big bangs and big crunches repeating like breaths. Which future feels truer to you? Eternal silence, fiery collapse, or endless rebirth? Or perhaps the universe will surprise us with something we cannot yet imagine. After all, who are we, tiny creatures on a single planet, to claim certainty about the fate of all things? But maybe the question is less about endings and more about meanings. What does it mean to live in a universe so ancient, so vast, so fleetingly luminous? Maybe it means this, that our small lives matter not despite the immensity of time, but because of it. That the brevity of our moments makes them shine more brightly, like candles against the long night. And maybe it means that by telling the universe's story, we give it voice. We, who live for decades, carry the memory of billions of years. We, who will be gone in a blink, hold the timeline of stars in our minds. Isn't that extraordinary? So, how old is the universe? It is 13.8 billion years. It is as old as the atoms in your bones. It is as old as the light now reaching you from distant galaxies. It is as old as memory itself. And yet, for you, for me, for all of us, it is always now. Perhaps that is the deepest truth. That no matter how long the cosmic past, no matter how vast the cosmic future, the only moment we ever live in is this one. And so I ask you, if the universe is 13.8 billion years old, what will you do with your tiny fragment of that history? Will you worry about its brevity? Or will you marvel at the miracle of existing at all within this ancient, shimmering span? Because maybe, in the end, time is not about numbers or ages or even the fate of galaxies. Maybe time is about presence, about noticing, about wonder, and perhaps that is enough. What is a second? When you glance at the ticking of a clock, what exactly is moving forward? Is it the little hand, the big hand, or is it you, slipping silently through the stream of time? It feels so natural to trust these measures. Seconds, minutes, hours, days. But what are they, really? Are they inventions or discoveries? Did time exist before we named it, or do we create it each time we divide it into neat little boxes? Close your eyes and imagine a world with no clocks, no calendars, no appointments. Just the rising of the sun, the phases of the moon, the turning of seasons. Could you still feel time passing, without the numbers to pin it down? Perhaps the earliest humans did just that. They watched the sky. They saw the sun arc overhead, then dip below the horizon. They saw shadows stretch, shorten, then stretch again. They saw the moon swell into fullness and shrink into slivers. They felt the chill of winter, the warmth of summer. Time was not numbers then, it was rhythm, it was cycle, it was change. But how did we begin to capture those rhythms, to count them? How did we first decide, this is a day, this is a month, this is a year? Think of the ancient Egyptians, gazing at the flooding of the Nile. Each year, the river rose, bringing fertile soil, bringing life. They realized this cycle matched the rising of a star, Sirius, in the dawn sky. So they marked the year measured not in numbers but in cosmic events. Or think of Stonehenge with its massive stones aligned to the solstices. Was it a calendar? A temple of time? Imagine standing there thousands of years ago, watching the sun rise perfectly between the stones on the longest day of the year. What was that moment to them? A reminder that time repeats? Or that humans can, in some way, keep pace with the cosmos? We began with the sky, but then we grew restless. A day, a month, a year, those were vast units. Too vague for the growing complexity of human life. Farmers needed to know when to plant. Merchants needed to know when to meet. Priests needed to know when to hold ceremonies. So we reached for finer divisions. Picture an Egyptian shadow clock. A stick placed in the ground, its shadow marking the slow passage of hours. Later, water clocks appeared, bowls filled with water dripping at a steady rate, measuring the invisible flow of time with each drop. Can you hear it in your imagination? Drip, drip, drip. Each one a tiny footstep of time itself. But how steady were those drops, really? Wasn't there still uncertainty? Centuries later, mechanical clocks emerged in medieval Europe. Great towers with gears, weights, and swinging arms. Suddenly, time was not just the cycle of day and night, but something regular, relentless, divided into hours, then minutes. And here is a curious question. Did these inventions measure time, or create a new kind of time? Before clocks, did anyone ever rush to be somewhere at 3 o'clock? No. They arrived when the sun is high, or after the first star appears. It was flexible, fluid. But once the gears began turning, life changed. Monks rang bells at precise times for prayers. Cities regulated work, markets, curfews. Time, once natural, became mechanical. And then railroads came. Trains needed to run on schedules across vast distances. Local time, tied to the sun, wasn't enough anymore. So we invented time zones, carving the world into slices of coordinated hours. Isn't it strange? For most of human history, noon meant the sun was directly overhead. But now, in many places, noon is just a number on a clock, while the sun lingers elsewhere in the sky. So again, what is a second? A day? A year? Today, scientists define a second with extraordinary precision. Not by the sun, not by dripping water, not by swinging pendulums, but by atoms. In a lab, cesium atoms vibrate at a specific frequency. Count 9,192,631,770 oscillations, and you have 1 second. That is our modern heartbeat of time. Invisible vibrations of atoms, measured with machines of exquisite accuracy. And yet, you don't need cesium to feel time, do you? You feel it when your coffee cools, when your hair grows, when you blink and realize the day has slipped by. So, whose definition is truer? The scientists or yours? Perhaps both. Perhaps time has layers, objective, measurable, cosmic, atomic, and subjective, lived, human, emotional. But here's another question. Do we live by time, or does time live by us? When you stare at a clock, watching the second hand creep, doesn't it sometimes feel like the clock is the one in charge, tugging you forward, dictating when to move, when to stop, when to begin again? And yet, clocks are inventions, numbers on dials. Humans built them. We set them running. Isn't it possible, then, that what we call time pressure is less about time itself, and more about how we have chosen to measure it? Consider this. A child at play may lose all sense of time. Hours vanish in what feels like minutes. Meanwhile, someone waiting for news might feel every minute like an hour. Both live in the same clock time, but not in the same human time. So which is real? The philosopher Augustine once confessed, "What is time? If no one asks me, I know. But if I try to explain it, I do not." Do you feel the same? You live inside time constantly, yet when you try to define it, it slips through your fingers. Maybe that's because time is not one thing. Maybe it is many things. Movement, memory, rhythm, change. Maybe time is not just measured. It is felt, remembered, anticipated. Let's return to the stars for a moment. A year is the Earth's journey around the sun. But the day? That is the Earth spinning once on its axis. A month? Roughly the cycle of the moon. So our units of time, though polished and precise, are still anchored to cosmic motion. And yet, notice what doesn't match neatly. Months don't divide evenly into years. Days don't divide evenly into months. Our calendars are filled with awkward numbers. 30 days here, 31 there, 28 or 29 for February. Leaps and corrections, patches and compromises. Doesn't that remind you that time, as we keep it, is a human weaving, a fabric stitched together to fit an unruly universe? And sometimes the seams show. Leap seconds, inserted to keep atomic time aligned with the slightly irregular spinning of Earth. Time zones that zigzag strangely across maps. Calendars adjusted by emperors, popes, governments. Time is order, yes, but also negotiation. And here is a deeper thought. Do other creatures experience time as we do? A hummingbird, wings beating 80 times a second. Does it feel life in slow motion compared to us? A tortoise, living a century, plodding steadily. Does it feel time stretch longer? Or is time simply different for them? And what about you? Haven't you felt moments that seemed endless, and others that vanished in an instant? Perhaps your perception of time says as much about you as it does about the universe. So what is a second? It is the tick of a clock, the beat of an atom, the rhythm of your heart, the memory of your childhood, the anticipation of tomorrow. It is science, invention, experience, all braided together. And maybe, just maybe, the deeper lesson is this: we do not just measure time. We live it. And to live time is to notice it. The pause before you answer a question. The silence between notes in a song. The way sunlight lingers in the late afternoon. Each second is both vanishing and eternal. Both gone and here. Both measurable and mysterious. So I ask you, the next time you glance at a clock, will you see only numbers? Or will you see the vast story they point toward? Of stars and seasons, atoms and hearts, calendars and lives? Because perhaps the secret is not to master time, or to fear it, but simply to marvel at the strange, beautiful fact that we are here, in it, together. What is memory, really? Is it a photograph in your mind? Or is it a doorway? One that lets you step backward, into moments you thought were gone. When you remember your childhood, perhaps a birthday, or the smell of your grandmother's kitchen, do you not feel as though you have traveled in time? Not with your body, of course, but with your mind? Isn't that a kind of time travel, too? Close your eyes for a moment and try it. Drift back to the very first place you can recall. Maybe it's a room filled with toys. Maybe it's a walk in the park. Maybe it's something as simple as sunlight filtering through curtains. How far away does it feel? How long ago? And yet, here it is, alive again because you called it back. So if science asks whether time travel is possible with machines and equations, perhaps memory asks it in a softer way. What if you already do it, every day, whenever you recall a moment? But here is the puzzle. How do memories form? Where do they live inside you? Neuroscientists will tell you that memories are patterns in the brain, networks of neurons firing in just the right way. A smell, a sound, a sight can awaken the network, lighting it up like stars in a constellation, and suddenly the past breathes again. And yet, doesn't it feel like more than electricity? Think of a favorite song from years ago. The first notes play, and instantly you're back. Driving down a road, or dancing at a wedding, or sitting quietly in your room with headphones on. The moment is not only remembered, it is felt. The emotions come rushing back, sometimes stronger than the memory itself. How can that be? If memory is only wires in the brain, why does it carry weight, warmth, sorrow, joy? Maybe memory is more like a thread, weaving the self across time. Each recall a knot, tying present you to past you. Without those threads, would you even know who you are? But then another question emerges. If memory is a form of time travel, how reliable is it? Science shows us that memories can be fragile. They shift, blur, even change. Sometimes we remember things that never happened at all. Sometimes two people will recall the same event in entirely different ways. So, is the time travel of memory a true window into the past, or a painting that keeps being retouched brushstroke by brushstroke, each time you look at it. And yet, perhaps that is not a flaw but a gift, because the past is not static. The meaning of your memories grows as you grow. What once felt ordinary can later shine with importance. What once hurt deeply can soften into wisdom. Have you ever noticed this? That a memory from long ago looks different when you revisit it now, as if the time traveler is not only visiting the past, but also changing it gently from the present. But if we can travel backward through memory, can we also travel forward? In a way, yes. For what is imagination but memory turned toward the future? Picture this: you're lying awake at night, thinking about tomorrow. You see yourself walking into a room, speaking to someone, catching a train, sipping your morning tea. You are rehearsing the future, traveling into it, living it before it happens. Isn't that remarkable? You hold in your mind both the shadows of what has been and the lantern light of what might be. Scientists call this mental time travel. The brain's ability to move both backward and forward in time, to simulate, to replay, to imagine. Some researchers even argue that this skill is what makes humans unique among animals. But is that true? Does your dog not anticipate the walk when you pick up the leash? Do birds not sense the coming migration, preparing their wings for the journey ahead? Perhaps imagination is not only human, but simply deeper in us, more elaborate, more detailed. Still, the mystery remains. How does the brain, right now, in this very moment, summon moments that are not here? It is as though the mind has a hidden theater. You close your eyes and the curtains part. Scenes play, characters appear, voices echo. And though it all happens inside your skull, doesn't it feel real? So, what is the difference between living a memory, imagining a possibility, and actually being there? The brain, it seems, doesn't always know. When you relive a memory, many of the same brain areas activate as when you first experienced it. When you picture the future, those same circuits spark to life again. It is almost as if, in that quiet theater, the line between past, present, and future begins to blur. Do you see what that means? Inside your mind, time bends. Just as Einstein showed it could bend around stars and speed, it also bends around thoughts. So maybe memory and imagination are the mind's own time machines. But here's another question. Why do some memories shine so vividly, while others fade into shadows? Perhaps it has to do with emotion. Moments charged with joy or fear or sorrow carve deeper grooves in the brain, making them easier to recall. That's why you might forget what you had for lunch last Tuesday, but remember with astonishing clarity where you were the day something extraordinary happened. And yet, even ordinary memories matter. They build the fabric of your identity. Every small detail, the way your kitchen smells in the morning, the feel of a favorite sweater, the laughter shared over nothing in particular. These threads weave together into the tapestry of you. Now consider this. If memory is so central to who we are, what happens if it falters? Think of amnesia. Think of Alzheimer's disease, where memory slips away, piece by piece. It is not just time that is lost, but a sense of self. Watching it unfold can be heartbreaking, for the person and for those who love them. And yet, even then, small sparks of memory can remain. A familiar song may stir a smile. A long-forgotten phrase may find its way back. It's as if memory, though fragile, has roots deeper than we know. Do you see the wonder here? Memory is not just storage. It is not simply data on a hard drive. It is life itself, replayed, reshaped, relived. So, if you can travel in your mind to a summer's day decades past, or to a future birthday you imagine with friends not yet met, then perhaps time travel is not only possible. It is happening constantly, quietly, inside you. Think of the way you tell stories. When you share a memory with someone else, are you not inviting them into your time machine? You take them by the hand, and together you step into your past. Your words become the engine, your voice the gears, and suddenly they can see what you saw, feel what you felt. Isn't that astonishing? That memory, once private, can be shared, carried across minds, across generations. And so memory is not only time travel, it is bridge building. Between past and present, between self and other, between what was and what might be. Let's pause here. Think of your favorite memory, the one that never fails to bring you comfort. Hold it gently. Notice its details, the colors, the sounds, the emotions. Isn't it alive still? Isn't it proof that the past is never entirely gone? And now imagine tomorrow. Not just in vague outline, but in color, in shape, in sound. Imagine waking, rising, greeting the day. Does it not feel real in some way? Does it not whisper that the future, too, is already here, inside you? So I ask again, what is memory? Perhaps it is time's way of letting you carry fragments with you. Perhaps it is the universe giving you a gift, the ability to hold both what has been and what might be, to fold them into your present moment like paper cranes. In that sense, you are always a traveler. You drift backward, forward, sideways in time, without ever leaving your chair. And though the physicist may search for wormholes and light-speed ships, you carry your own vessel inside you, built of neurons, emotions, stories, dreams. And maybe, just maybe, the real marvel is not whether we can invent machines to travel through time, but whether we can notice the miracles of time travel already within us. So, tell me, where will you go tonight, when you close your eyes? Backward to a childhood memory? Forward to a dream not yet lived? Or perhaps you'll linger here, in this very moment, letting time pass not as seconds, but as stillness, as breath. Because in the end, perhaps memory is not about escape nor about control. Perhaps it is simply about presence, the presence of all yourselves across time, meeting here in the now. And isn't that, in its own quiet way, the most extraordinary kind of time travel of all? What is time, truly? Is it a river that flows endlessly forward, carrying us on its current whether we wish to move or not? Or is it a vast ocean, stretching in all directions at once? Every wave a moment that already exists, waiting to be touched? And if it is an ocean, are we swimmers, drifting across its surface? Or are we fish, unable to see the water that surrounds us, unaware of the depths in which we live? For all our clocks and calendars, do we really know what time is? Physicists measure it with precision, slicing it into nanoseconds, into Planck moments so small they defy comprehension. Philosophers ponder it, poets sing of it, musicians weave it into rhythm. And still, the mystery remains. Is time something we move through, or something that moves through us? Pause for a moment. Feel your breath. Inhale, exhale. What just happened? Already, your last breath belongs to the past. Already, the next breath belongs to the future. And yet, here you are, suspended in the present, a vanishing sliver, thinner than thought, thinner than light. How can something so fleeting feel so vast? Think of a sunset. You watch the sky turn golden, then orange, then violet. Each second melts into the next, but in memory it becomes a single event, the sunset. Did time slow down, or did your mind expand, stretching one moment into eternity? Perhaps time is not fixed at all. Perhaps it is elastic, shaped by the weight of experience. An hour in boredom feels like forever, while a joyful evening vanishes in an instant. So, is time measured by clocks or by hearts? If you could step outside of time, just for a moment, what would you see? Would the past lie behind you like footprints in the sand, and the future ahead like an untouched path? Or would everything, birth, life, death, stars being born, galaxies colliding, exist together all at once, in some grand cosmic tapestry? Einstein's equations hint at such a view, that past, present, and future are not separate, but woven into spacetime, like threads in a fabric. What we call now may simply be the point our consciousness touches as it slides along the weave. And if that is true, then perhaps time travel is not about breaking the rules of the universe, but about learning how to look sideways along the threads. But here is the question. Why do we long for it so deeply? Why are humans so fascinated by traveling through time? Is it nostalgia? A yearning to revisit what has been lost? Is it hope? A desire to glimpse what lies ahead? Or is it something even deeper? A sense that time itself is not a prison, but a mystery we are meant to explore? Perhaps you've felt it yourself. That pull. Standing in an old place, you imagine the footsteps of those who walked there before. Holding an heirloom, you picture the hands that once held it. Looking at the stars, You realize you are seeing light that left its home millions of years ago. In that moment, are you not already touching the past? And when you plan, when you dream, when you imagine tomorrow, are you not already reaching into the future? So maybe time travel is not something to be invented. Maybe it is something we are already doing, constantly, in small ways. But then, another question arises. If time travel were truly possible, in the mechanical, physical sense, should we do it? Imagine the temptation to go back and undo mistakes, to save lives, to relive moments of joy, to meet long-lost loved ones once more, or to leap forward and witness the marvels of centuries yet to come. But what of the dangers? If you could change one event, would it not ripple outward, altering everything that followed? The so-called butterfly effect, where a single flap of wings changes the course of storms. Could one person's visit unravel the world as we know it? And if the future can be seen, would it still be free? Or would we live trapped in destiny, unable to change what is already known? These are not just questions of science. They are questions of ethics, of philosophy, of the soul. Maybe that is why the universe keeps its doorway to time hidden. Not because it cannot be built, but because we are not yet ready to walk through it. And still, we wonder, what if the travelers are already among us, invisible, careful, slipping between moments like shadows in the corner of the eye? What if déjà vu, the strange sense you've lived a moment before, is their footprint brushing lightly against your timeline? Or what if time travelers cannot alter the past, but only witness it, quiet observers, like historians with perfect access? Right now, as you read these words, could someone from the far future be watching you, with curiosity, with tenderness, with awe? The questions multiply, like reflections in a hall of mirrors. But perhaps we do not need answers to be at peace. For isn't the wonder itself enough? Isn't the act of questioning, of letting the mind stretch beyond the limits of the present, already a kind of journey? When you sit quietly, thinking about the vastness of the cosmos, or the smallness of your own heartbeat, are you not traveling across scales of time, cosmic, biological, human, all at once? And perhaps the truest form of time travel is simply awareness. To notice the moment you are in, to feel its texture, to realize that it will never come again, and yet, in memory, it will never be entirely gone. Think of the people you love. Each shared laugh, each quiet conversation, each hug. Those are time machines, too. For when they are gone, the memory will carry you back, tenderly, into their presence. So maybe time travel is not only about wormholes and black holes and paradoxes. Maybe it is about cherishing the fleeting, and in doing so, giving it eternity. Isn't that beautiful? And yet, let us dream bigger still. For what is science if not dreaming? If one day humanity does unlock time's doorway, what would you wish for? A single visit to the past? A long journey into the future? A chance to live beyond the bounds of now? Would you seek knowledge, or comfort, or adventure? Or would you, perhaps, step through once, and then return grateful to the present? Because maybe, in the end, that is what time travel teaches us. That the present is precious, not because it lasts forever, but because it does not. Your life is a thread in the fabric of time. Fragile, luminous, unrepeatable. To live it fully may be the greatest adventure of all. So, the final question is not, is time travel possible? The final question is, what will you do with the time you already have? Look around you now. Listen to the quiet hum of the world. Feel the steady beat of your heart. This moment, right here, right now, is yours. And in some distant future, perhaps you will look back and remember it and travel here again. And in that sense, you are already a traveler. You always have been.